Welcome back, students, and today we are going to discuss the concept of divisibility rule. Again, I am not going to explain any lecture about divisibility rule, we had seen already a lot. I am going to explain only the previous year questions which are all they asked you by using divisibility rule, right. Okay, so let us see PYQ of 2023. Last year we had this question: for any choices of values of x, y, z, the 6-digit number of the form of xyz, xyz is divisible by, the numbers are given. Look at the options first. They are asking for check by 7 table, then 11, 11 and 13, 7 and 13, 7, 11 and 13. So no other choices, we need to check all 7, 11 and 13 tables. And numbers are not given, they gave only the variables x, y and z. So we need to take one number and we need to check. Generally I know that what candidates are doing in their examination. I am going to explain a small new thing about this sequence x, y, z, x, y, z. Okay, if I take any numbers like 1, x is equal to 1, y is equal to 2 and z is equal to 3, again the same variables, right, x, y and z. So let us take the same numbers again. So 1, 2, 3, 1, 2, 3. If you want to check, let us take 1, 2, 3, 1, 2, 3 divided by first 7 table. You need to check with 7 table. 7 table we had a logic. Last digit, split the last digit, multiply by 2 and subtract that answer with the remaining number. If 1, 2, 3, 1, 2 and 3 into 2 is 6, minus 6, right. So what you get the answer, again split the last digit, multiply with 2 and subtract with the previous one. If you feel that this is not easy, just you can do one thing, directly you can divide the number, right, 1, 2, 3, you can divide the number directly. 12, how many times, 7 times, remainder 5. So like that you can check. So that is your problem, this is not, you do not have calculator. So according to your speed you can divide this number, so it is divisible by 7. Okay. Next again take this number 1, 2, 3, 1, 2, 3. Now we are going to divide this number by 11 table. So for 11 table we know the process, that is very easy. I am going to take the alternate numbers 1, 3, 2, right, 1 plus then 3 plus 2, alternate place, odd positions first, even positions next. Now take the even position, even place numbers, that is 2 plus 1 plus 3. Now I need to add both the numbers and take the difference. If you got 0 or 11 or multiple of 11, then the entire number will be divisible by 11. That is the concept. So 2 plus 3 is 5, 5 plus 1 is 6, I got 6 here. Then 2 plus 1, 3, 3 plus 3 is 6, again 6, 6 minus 6 is 0. So this number will divisible by 11, right. And the next number is, let us take 1, 2, 3, 1, 2, 3 divided by 13, again a prime number. Somebody knows that what is the divisibility rule for 13, and not every candidate knows this. Actually for 13 table again the same process what you did for 7 table, split the last digit. For 13 table you need to multiply this with 4. 4 into 3 is 12. So 1, 2, 3, 1, 2 plus 12, right. So I will get 1, 2, 3, then 12 plus 12 is 24, right. Again I need to split the last number, multiply by 4. 4 into 4 is 16. So 1, 2, 3, 1, 2, 3, 2 plus 16. Okay, what you will get? 8, 4, 1, 2. Again split the last digit, multiply by 4, again do the same. Then you can get it at last. If you find that it is multiple of 13, you will get the answer. That is the process, but here I got headache because it also takes more number of times, right, 3, 4 steps it takes. So how can I do all these 3 in quicker manner? So generally all of the students did this in their examination, but if you know one concept, one shortcut, one magic things in series of this x, y, z, you don't need to do all these things, you can get the answer quickly, right. I am going to explain that now. Listen this. See, the thing is, whenever I had a same number, before that I will take one favorite number, magical number 1001. Keep this in mind. Okay. Whatever the numbers, if I multiply with this 1001, right? 1001 into 243. Everyone, please take your calculator and do what I am doing here. You can know that 1001 times 243, I will get the answer 243, 243. I will get the same sequence 2 times. If I take again 1001 times any other number, 725, right? I will get the answer 725, 725. This is my final answer. Okay. And if I take 1001 times 528, my answer will be 528, 528. Okay. Please check this, and you can do this after this session. You can try 1001 into 2 digits also. In between that, there will be a 0. Okay. So this is the concept of 1001. So that is why they ask this question. If you know this, you no need to divide by 7 or 13 or 11. Directly you can tell the concept. What is happening behind this? Listen, 1001 with whatever the number I gives, it gives 2 times the same sequence, right? So what is this 1001? Next, everybody take your pen and paper and take 1001 and take the prime factors. What you will get? 1001 is nothing but, you can divide this number using 11. Okay. 11 into what number? 100, how many times? 11, 7, 900 in 11 table, 99, right? 9 times 99. And remaining 1, so 1, right? I got 91. I think in previous sessions, in these videos itself, I had said 7 into 13 is 91. Always keep this for every 5 or 10 questions, you can face these numbers, right? 7 into 13. So 7 times 13 is 91. This is nothing but, what is the question they asked? We need to check for 7 table, 11 table and 13 table. So 1001 is nothing but 7 into 11 into 13 is equal to 1001. This number only doing all these problems, right? So whatever the number multiply with this, I will get the same sequence. So they clearly says that here I got XYZ and XYZ. So XYZ, XYZ. If you get 2 times, means that is nothing but definitely these number will multiple by 7 and multiple by 11 and multiply by 13. That gives 1001. 1001 multiple of whatever the number in the place of XYZ, 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 you will get same numbers 2 times. That is why they ask this. If you know this concept, directly you can pick option D is the right answer. Is it clear? So this is the idea behind this logic, right? Let's move to the next question. Let x be a positive integer such that 7x plus 96, right? So 7x plus 96 is divisible by x. It is divisible by x. How many values of x are possible? Okay, how many values of x are possible? Okay, now look at this. When I look at this number, already in remainder theorem we had learned one thing. Whatever in the denominator, if I take the denominator value and multiples, it's getting cancelled, right? So whatever it is, 7 into x or x into 7, that number, if let's take x is 2, right? If x is 2, 7 into 2 is 14. So 14 and x getting cancelled easily. So these numbers will getting cancelled. The remaining is nothing but 96 over x. Now I need to find how many values of x are possible. So I need to find out how many values, how many numbers are divide this 96. So if how many numbers divide this 96 means I need to find out the factors of 96. Those number will divide the 96, right? Let's take 96. If I take only prime numbers we need to use, so let's start from 2, 4 times 8, remainder 1, 16, 8. Then again if I take 2, 2 times, here 4, and again 2, 1, 2, 12, then 2, 6, then 2, 3. Look at this, how many 2's? 1, 2, 3, 4, 5. So we can write 2 power 5 into 3 is 1, 3 power 1. Generally using the prime factors we can write like this, 2 is 5 times and 3 is only 1. But if you want to find LCM and HCF you can use as it is, but here we are going to find the factors. So many students asking me that, sir, how to find the factors, number of factors. If I want to find number of factors, that is nothing but, see, a power n into b power m. This is the prime factorization, right? I need to add 1 with these values. Just add 1 plus 1 and plus 1. Okay, what you will get, n plus 1, and another one is m plus 1. Just multiply these numbers, that is number of factors. That's it. This is the formula. Okay, if you had a doubt, just check this. So here I am going to add 1 with this 5 and add 1 with this 1. So 5 plus 1 is 6 and 1 plus 1 is 2, 6 into 2 is 12. So 12 numbers are there, can divide 96, that is the right answer. So if you know this directly you can get this. Whatever this factors of 96 you can divide it by, in the place of x, the number will be divisible. So those are the number, how many numbers, right? This is the answer. Clear? Okay, let's move to the next question. How many 3-digit natural numbers without repetition of digits are there such that each digit is odd and the number is divisible by 5? So we got one easiest way of getting answer. I hope nobody will skip this problem because it is very, they gave an easy way, a clue, that is it should be divisible by 5. First we should understand that which numbers are divisible by 5. When a number is divisible by 5, definitely that number should be ending with 0 or 5. Then only it will be divisible by 5. Keep this in mind and go to the problem. How many 3-digit numbers? So let's take a 3-digit number without repetition, okay, or they are such that each digit is odd and divisible by 5. So digits are what? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are all the digits, 0 to 9, and they need only the odd numbers. So first pick only the odd numbers. So I don't need 0, then 2, 4, 6, 8. So remaining numbers are 1, 3, 5, 7 and 9, right? Now these numbers should be divisible by 5. That means this last place I need either 0 or 5. Here 0 should not use because they need an odd value. The only thing is 5. So this 5 I can write here. One number I am going to write here. Out of 1, 2, 3, 4, 5 numbers, one number I am going to place here. So here they says that without repetition. So hereafter we can't use this 5. So one number I placed here. I am writing not 5. Why sir you don't write 5 here? Means I am writing 5 only. But I am denoting this number, that is one number. I am writing this as a permutation. Okay. So 5 only I am writing here as 1. Okay. Next, if 5 is written, how many remaining numbers are there? I had 4 numbers. Out of the 4 numbers, any one number will be placed at the first place. From the 4, 1 will placed at the first place. The remaining numbers are 3. from the 3 numbers, any one number will be placed here. So our answer will be 4 into 3 into 1. So 4 into 3 is 12, 12 into 1 is 12. So 12 is the right answer. Got it? Right, next question. The number 3798125P369 is divisible by 7. What is the value of the digit P? So different types, so many of them are explaining this question, but what students did in the exam, directly they are dividing this number, or we need to put in the place of P, in the place of P. Some students did this. In the place of P, I will write 1, then I will write 6, then I will write 7, then 9, and I need to check with the divisibility of 7. So what we did, we going to do in the exam, right? At last we need an answer. So we did all these steps, but don't do that. Everything behind a concept, whatever they are asking, definitely there will be a ideology or a cycle, a constant values behind that. We should know, right? Okay, let me explain why they are asking this question. Okay, generally for divisible of 7, in the previous questions I had explained, split the last digit and divide it, everything is right. But for larger number, we had a cycle. If you know the cycle, it will be very easy. Let me explain that. Listen. Don't go for this question. I am just, for an example, I am explaining this number. This is a very big number. I am going to divide it by 7. I am not need any answer. I want to know whether this number is divisible by 7 or not. That is enough. In those cases, we can use this trick. I just take these numbers in from last three numbers. That is the logic. Please listen carefully. See, from the last 3 numbers, then 3 numbers, then remaining numbers, remaining 3 or 2 or 1, whatever it is. Okay, I just going to take. Okay, so from the last only we need to take. First starts with plus, then next set I starts with minus, and next set plus. If we had another set, again minus. Okay, now look at this. Take this number 864 divided by 7. This is not that much of difficult for us for getting a remainder. Okay, 8 we had 1 7, remainder is 1. 16, 7 into 2 times is 14, remainder is 2. 24, 7 into 3 is 21, remainder is 3. So here I am going to write 3. Okay, next number is 197. Now divide this number with 7. 19, 7 2s are 14. What is the remainder? 5. 57. Right, 7 7s are 49. Right. So 7 7s are 49. Then here we had 7. Okay. Then 7 into 8 is what? 756. Remainder is 1. Okay, 56, remainder 1. So I am going to write 1 here. Let's take the third set. 523 over 7. 5 is not divisible by 7, so take 52. Again 7 7s are 49, remainder is 3. 33. 33 means 7 into 5 is 35. So 7 into 4 is 28. 3, 4, 5. Here I got 5. Now look at this. Take this remainders. See, for first one I got plus 3, and for second one I got minus 1, and for third one plus 5. Just do this calculation. Minus 1 plus 3, 2. 5 plus 2. 5 plus 2 is 7. If I got 7, this number is divisible by 7. I got it. Otherwise, if I am not getting 7, it is not divisible by 7. This is the simplest way. Okay, let we take one more problem also. Look at this. See, take this number. Now we going to split from the last three numbers, right? Look at this. First 3 numbers is 861, and next 3 numbers is 523. Okay, and again next 3 numbers is 197, and here 8 64. So 1, 2, 3, 4 sets, right? From the last, I need to put the symbols. First starting with plus, then minus, then plus, then minus, right? Okay. So divide by 7, what is the remainder? 8, 1, 7, remainder is 1, 16, 2, 21, remainder is 0. Now, if I divide this number with 7, 52, 7 sevens are 49, remainder 3. Here 33, so 33, 35, no, yeah, 33, 7 sevens are 49, it's a 3 only, right? Yeah, 7 sevens are 49, remainder is 3, 33, 35, so 7 fours are 28, 5. Now, let's divide it by 7, 7 twos are 14, remainder 5, 57, we got 56, 7 eights are 56, so remainder 1. Now, if I divide this number by 7, 1 remainder, so 2 remainder, 24, here I get 3. Now, take this number minus 3 plus 1, then minus 5, then plus 0. 5 plus 3 is 8, minus 8 plus 1, what is that? I get minus 7. Minus 7 divided by 7 is divisible by 7. So, at final case it is positive or negative. If I got 7, the entire number will be divisible by 7. So, I hope now you understand how to know whether this number is divisible by 7 or not when it is a very big numbers. Now, let me do our problem. So, what is this? Look at this. Let us take the same numbers. First, these 3 numbers, 369, right? Then 3 numbers, 2, 5, P, right? Next 3 numbers, 981, right? And only 2 numbers we had. If you want, you can add 0 here. Okay, let us take divided by 7, divide by 7, divide by 7, divide by 7. I need to know whether it will be divisible or not. Okay, so 37, and one more thing, first plus, then minus, then plus, then minus, right? Now, 7 5s are 35, remainder is 2. 9 we had 1 7, remainder 2, 28. 28 is divisible by 7, so remainder is 1. Next, let us take 250 plus P, right? If we had a 250, I don't know the P value. If P value is 1, it will be 251. P value is 6, it will be 256. P value is 7, 257. That's it. So, let us take 250 plus P. Okay. 25, 21. So, remainder is 4. Okay, leave this. We will do it later. Okay. Now, 35, remainder is 1, 19. 7 2s are 14, remainder is 5. Now, take these values minus 2, then plus 1, then minus some number will came here, then plus 5. 5 plus 1 is 6, 6 minus 2. 6 minus 2 is what? 4. If 6 minus 1 is 4, here I need one number to divide this entire number. So, what number I need here, right? So, for when we get divided by 7, see one number divided by 7 means here I need 7, right? Already 4 is here. If I got 0, plus 4 is there. If I got minus 4 or multiple of 7, then only it is divisible by 7, right? So, look at this, minus 2 plus 1 plus 5, I got 4. Still now we got 4. Now, what is the P value? Look at this. If I take 1, that means 251. Let's check one by one very faster. 251 divided by 7. What is the remainder? We are checking the remainder. 21, remainder 4. So, 41. You get 6. If I write 6 here, what will happen? If I write 6 here, then automatically minus 6 plus 4, it will be minus 2. Minus 2 by 7 is not divisible, right? Okay, let's take the next number, 6. If I write 6, 256, 256 over 7. What is the remainder? 21, remainder is 4, 46. 46 divided by 7, we get 42, remainder is 4. Now look at this, if I write minus 4 here, plus 4, minus 4, it's 0. So it's 0. What will happen? Automatically it is divisible. Either I need 7 or 0, right? Because I am checking only the remainders. Now look at this 7. If I write 257 divided by 7, what will happen? 25, 21, remainder 4, 47, 42, up to 42 we will get. Remainder is 5, right? If I write 5 here, minus 5 plus 4, what will happen? You will get minus 1. Minus 1 divided by 7 is not divisible, right? And last one, 9. If I take 9, that means 259 over 7. Remainder 4, 49, it is 0. If you write minus 0 here, your remainder will be 4. 4 by 7 is not divisible. So the only option is, if I use 6 here, 256, I use 6 here, automatically I get minus 4. So look at this, minus 2, minus 4 is minus 6, 5 plus 1 is 6, plus 6 minus 6 getting cancelled, remainder is 0, automatically it is divisible. That's it. Is it clear? So once you know the concept, it will be very easy. Just checking with the alternate 3 digits. Okay. Next question. Right. Consider all 3-digit number without repetition of digits obtained using 3 non-zero digits which are multiples of 3. Let us be their sum. Which of the following? From that, yes, they are asking 2 statements, right? Let me solve this. 3-digit number without repetition of the digits obtained using 3 non-zero digits with multiple of 3. Multiple of 3 means, look at this, I can take 3, 6, 9. This is the only numbers or multiple of 3. But that 3-digit number should be mingle of these numbers, right? I need to swap. Generally, for 3 numbers in permutation, how many 3-digit numbers can be formed using 3, 6, 9? If I ask a question like this, I will use 3 factorial. So 3 factorial is 3 into 2 into 1, that is 6. I get 6 combination, but here I need to write that 6 combination because at last they says I need to find out the S value, that is sum of the numbers. So 3, 6, 9 is one set, then 3, 9, 6 is other set, then 6, 3, 9, 6, 9, 3, 9, 3, 6, 9, 6, 3. Right? These are all the 6 combinations of numbers, but they want the sum of these numbers, right? So what is the sum of these numbers? 9, 9, 18, then again 9, 27, then one more 9, so 27, 36. 6 and remainder 3. Okay. Again 9, 18, 27, 36, 9. Remainder 3. Right. Next 9, 18, then 27, 36, 39. Okay. So this is the total value. This is called S. Okay. Now come to the statements. Look at this. Right. S is always divisible by 74. Now I need to take this 3996 and divide it by 74. No other option. You need to divide it. Okay. But you can do one thing. 74, if I broke this, I will get 2 times 37. 2 and 37, 2 into 37 is 74. This is co-prime number. This is unwanted, but even though if you are facing trouble for dividing this number, you can minimize the number using this. So this is co-prime. If you don't know, please check what is meant by co-prime. If HCF of the given number is 1, that is called co-prime. If it is a co-prime, if one number is divisible by 2 as well as 37, definitely that number will be divisible by 74. So now it is easy. This number is divisible by 2? Yes, divide by 2. Now 39, look at this. This is very easy, right? 39, 37. So remainder is 2. Right. Now take this 296 divided by 37. It is 4 times, right? That's it. So the given number is divisible by 74. This is right. And the next one, S is always divisible by 9. See, look at this, 3996 divisible by 9. What is the rule for 9 table? Just cancel the 9. 6 plus 3 is 9. There is no remainder, so it is divisible by 9. That's it. Both are right. So both 1 and 2 is right. That is the answer for this numbers. Is it clear? Yes, that's it. So the previous year's divisibility rule questions up to 2021 we had seen here. The divisibility rule have definitely a logic. That logic had co-primes, right? That logic had same sequence x, y, z, okay, and it had cycle. So if you know those things, whatever the question is asking in divisibility rule, it will be very easy, and it is more important topics too. So all the very best, guys. Keep practicing. Thank you.